Okay, good afternoon, ladies and gentlemen. I feel a little bit like a station announcer with all the background noise. So the train will be leaving at 1:45. But meanwhile, let's get in quickly with some stuff about banned password, hybrid identity, how it all fits together. So I want to start with just looking at, where's your password? Where is the password? Banned password detection, how that takes place, and then adding banned password detection to on-premise AD. So how do we sort of close the loop and have banned password detection absolutely everywhere? So, types of user, cloud-only user. This is a user purely homed in the cloud. Their password obviously is in the cloud. And if we're changing the password, it's all cloud interaction, no on-prem interaction. We then have a hybrid user, and this is a user with their source of identity coming from on-prem. And what we've done is using Azure AD Connect, we've taken their identity up into Azure AD. And the question is now, how do we authenticate those users? So I want to go through that and look at that. And then external users, and here we're talking about sort of enterprise identities, B2B, and this is someone coming from B2B from another Azure directory. But you've probably seen that we've also got the ability to now federate with Gmail, as in a B2B federation with Gmail, and watch the space for additional federations in the near future. Now, with those, and also if we're bringing in social identity, we're going down the B2C route, all of that is done in the other identity provider. So we're not going to be in charge of their password at all. So we can eliminate external users, right? Because we're not have any control of their password changes. They have to be done by the other entity. So let's have a look at hybrid users. So hybrid users are synchronized up from on-prem. They come into our Azure AD, and the question is now, how do we authenticate those hybrid users? Well, one of the ways is to use password synchronization. I've deliberately said synchronization because that's how Microsoft sold it for a long, long time. And chief security officers threw their hands up in horror and said, no way are you syncing my passwords up into the cloud. And it was in the days of where a password filter DLL was used for lots of things, and people thought it was exactly the same thing. You'd have a password filter DLL, captured the password change on-prem in the clear, and synchronized it up. The reality was, it is something totally different. Number one, we take the MD4 hash, we salt it, and then we put it through 1,000 iterations of HMAC SHA-256, and then it gets put up into the cloud. So once it's been salted, even if you could steal it, which would be extremely difficult, as it's salted, you can't do rainbow attack on it, and as it's gone through 1,000 iterations of HMAC 256, people are not going to bother to break it. People are looking for low-hanging fruit when they steal passwords. That's one way of operating. The good thing is for us is our password is actually in the cloud itself. So when we sign in, everything is done up at the cloud level. Also, because our password from on-prem is in the cloud, we can use identity protection in terms of actually looking for leaked credentials. So if you've got a P1 license, leaked credentials will be put into the logs. If you've got a P2 license, then you can do conditional access based on risk. And one of those risks is leaked credentials. Next job, pass-through authentication. And pass-through authentication came out last year. And here, we take our username and our password, we gather it in the cloud, and we pass it down through a secure channel down to on-prem. And it just uses the Win32 API to log the user on. It's an actual log on from the endpoint, which is sitting down. So the authn agent sitting down on-prem, we're actually authenticating directly to our on-prem password. By not having password hash sync, we've lost the detection of leaked credentials. And then finally, we can do federation, and it could be with ADFS, it could be with some other identity provider. And what happens now is we come along to Azure AD, and all it needs to know is the domain we're from. right? Because based on that domain, it's going to say, aha, you're a federated user, and it's going to redirect you down to your on-prem ADFS server or another identity provider on-prem. And so we can put in our username, and immediately, of course, the DNS suffix on there, we detect it, we know that's a federated domain, or we can use a thing called domain hints. And if we use domain hints, what will happen is we'll pass straight down. Okay, so if you're out on the internet, then you will end up at a proxy. If you're sitting inside the corporate network, you'll end up going directly to the ADFS server, and provided you've got Kerberos configured correctly, then it will be seamless sign-on, so single sign-on, because you'll just pass Kerberos credentials through to your ADFS server. Again, by going with this method, we don't have password hash sync. So the recommendation is to always have password hash sync, because using password hash sync, you get the leaked credential detection. Okay. So, and if this fails, how do you fail back? Well, the fail that back would be to using password hash sync. Makes it a lot easier. If your on-prem ADFS infrastructure dies, or even worse, and I've seen this recently, the AD gets completely flattened by a cyber attack, right, you can still log in because you can fall over to, or fail over to, password hash synchronization. So the next question is, what happens to our on-prem passwords? If we're using password hash synchronization, those passwords are replicated up within 2 minutes of being changed on-prem. So up they go. So that's with password hash sync enabled. Now, if we want to actually reset a password, so we want to reset a password, whatever method you're using, even if you're using password hash sync, where have you got to reset it? You've got to reset it on-prem, because that's the source for your password. If you're using pass-through authentication, you've got to reset it on-prem. If you're using ADFS and you want to reset it via a cloud, then you've got to reset it on-prem as well. So all of these require password write-back. How do we enable it? One little checkbox in Azure AD Connect. So it's very easy to configure. Works for passwords reset by an admin. Works for when a user resets a password. Also works with password self-service reset. It's a synchronous operation. So we change the password in the cloud, and then it goes down through a secure channel to on-prem. And now the password is changed on-prem. Well, if your on-prem password policies reject the password, a little message comes back up into the cloud and says it's not allowed from on-prem password policies. So the advantage is you've got complete on-prem password policies in place. It doesn't allow you to change passwords for protected on-prem accounts. And the question is, what is a protected on-prem account? Anyone know how you can immediately tell if you've got a protected on-prem account? Yeah, admin count. There's an attribute called admin count. And if it's greater than 0, you are protected. And as a protected account, it's really to protect sensitive administrator accounts. If you have an admin count greater than 1, then what will happen is you can't change that user's password in the cloud. The reason and why it's been done is so that a cloud administrator can't suddenly take over on-prem. But it could mean you could actually have quite a number of users who are protected. The other thing to be careful about, if you put a user into your domain admins group, you will become protected. All right? And what a lot of people are doing, of course, is reducing the number of administrators, so they're pulling them out of domain admins. But guess what happens to the admin count value? It doesn't get cleared down. So now you've got a whole bunch of protected users who aren't administrators, and they can't change their passwords in the cloud. So you need to go and set that admin count value back to 0. Ban passwords. So ban password changes. If we change it in the cloud, then immediately it's looked at against a Microsoft global ban password list. And it's a small number of passwords that are actually banned. However, what they do is they take the password and they put it all to lowercase. And then they do upper lowercase substitution throughout the password, all right, before deciding something you've put in might be banned. They also look at the standard character replacements. So, password WO, which is replaced with a 0. They'll check all those sorts of things. Also, an @ being used for an A, and an E, a 3 being used for an E. So overall, it's sort of really looking at something about 1 million potential variations. If you want, you can create a custom password list. This has been available in the directory for quite some time, but it only got lit up in the UI very recently. We can create it in the UI. Previously, what you had to do is you had to create a template and load the template into Graph. Right? But now we've got the ability of putting in our own custom list. So obviously your company name, which Microsoft may not think is a global band name at all. And then project names are always good to have in that list. And then we found that the best and worst boss ever is always worth putting in. People seem to pick on that as a primary password to be used. So in terms of creating the custom list, we go into the UI, and we go into the UI, we go to security, we go down to authentication methods, and here what we've got a number of things. The custom smart lockout. Smart lockout is used when we're using pass-through authentication. Because remember, with pass-through authentication, we're gathering the username and password in the cloud and passing it down to an on-prem agent. So what will happen is we will actually then do a log-on directly on-prem. Well, you could attack the cloud, and then you could lock out your on-prem. And the concept behind the smart lockout is to protect against that. Putting in our banned password list, we can do that. And this is putting in a custom list. So remember, then you'll be checked against the global list and also the custom list. And then down here is where we turn on for protection for on-prem AD. Right? And notice we can go enforced or audit. Right? Because when it comes to banned password, you probably want to do some user education to help them choose passwords. I've seen people stuck trying different things, summer 2018, we'd never use that. So they go, okay, well, it's going to be winter soon, winter 2018. And they need some help and encouragement as to how to actually manage their password changes. Well, one of the things you can do is you can put it into audit mode, and you can see how many people are being rejected. So it almost tells you how much education you need to bring into the organization. So password checks. This is the entropy meter when you go to change your password. And like all entropy meters, it is pretty useless. As in, what do you look for? So if you put in a random string of 5 characters, it will probably mark that up as a weak password. Whereas if you put in something like, password where the A is swapped for a @ and the O is swapped for a 0, password 1 might well get through the entropy meter. Right? So these have always been a problem. So we can it's strong, yeah, great, but it's probably not really. So the next thing that happens is, having got this far, we've put in our new password, and now it's checked. So the global password list is always running. So what it's saying here is choose a password that's harder for people to guess. All right? And it sort of gives it away a little bit, because this is coming out the global list. If it's a password from the custom list, it actually says, unfortunately, you can't use that password because it contains words or characters that have been blocked by your administrator. All right? I would prefer not to have that differentiation between the global and the custom list. I'd just like to see one message. All right? But that's the way it's currently done. By the way, actually quite a few years ago, when they first started trying out banned passwords, I got caught. I was doing a presentation it was actually in the Netherlands, and I was putting a virtual machine together, and I set the password in the virtual machine, and suddenly I saw this little spinning wheel. And I thought, I've never seen that before when I've changed a password or set a password. And it spun for a bit and came back and it said password too common. So I put in a much more complicated password, little wheel going round and round, password too common. So, you know, I knew I wasn't going to get it any further. And so I just said, look, I'm really sorry, guys. It's not working. However, I will be writing to Bill Gates. How dare he call my wife common? And I got away without being dinged for the demo, which was very nice. Because normally, you know, one demo goes wrong, and the thing is, feedback is all the demos went wrong. Well, I got away with that. So, yeah, I was caught the other day. They turned up the aggression on the banned password list, and I did get caught trying to change passwords. So, self-service password reset, you get a pretty similar message. So, unfortunately, password contains a word or phrase pattern that makes it easily guessable. I mean, again, I would love these messages to be consistent throughout the UI. Because to have, you know, if you change your password and then if you go to self-service password reset, you're getting different messages. I prefer for that not to happen. And again, here you've got something in the custom list, which is again pointing at your organization that has actually banned the password. And then you've got, if you actually go for the changing the password for a hybrid user, you get a slightly different UI, but the same messages are coming back if the password is detected and blocked. So that's the user experience in the cloud. Okay. So if we want to go on-prem, what we need to do is remember, sorry, I've jumped one slide in my mind. If we're changing the password in the cloud, we might get away with it. The entropy meter might say strong. We might not be banned. And remember, it's going down to on-prem now, synchronously, and it's being applied against on-prem. So now we're changing the password on-prem, and here you get a message: the password does not meet the length, complexity, age, history requirements. So this is being blocked by the on-prem policy. So we won't get here unless we get through the banned password list. Okay, if you want to protect on-prem, then we've got to detect the password change. So this is protecting on-prem password changes. So this is, if we're doing it in the cloud, it's all there already. If we want to change a password on-prem itself, what we've got to do is capture the change on-prem. And we've got to be able to look at it and analyze it for a bad password. So it's no good getting the MD4 hash or something like that. So what they've got is a password filter DLL. That has to be deployed on every single writable domain controller. You don't put it on an RODC, because if you go to make a password change in an RODC, what will happen is it basically will refer you up to a writable DC. So now we've got this password filter deployed. The password filter is going to be past the password in clear text. Now, if you've already got password filters for some other, maybe you've got some sort of maintenance thing for maintaining passwords, and you've already got a password filter installed, they are designed to chain. So you go through each password filter reports success or failure, and then having got the aggregated success or failure out the end, it then informs every filter the overall result. So we can chain these together. Now, these guys work with an agent, which is on every DC, and the agent is going to check the password that is snagged by the password filter DLL against the banned password list. So the question is, how do we get the banned password list? We deploy a proxy, and this is part of the this configuration. We deploy a proxy which connects up to Azure AD and pulls the banned password list. One of these guys talks to the proxy. Right? You can have them all talk, but it only needs one. You use an RPC call into the proxy, gets the banned password list, and pops it into sysvol. and then sysvol replicates across all DCs in the domain. If you're multi-forest, right, you've got to basically arrange for each, we've got to arrange for one agent in each forest to actually connect out through the proxy. So very, very easy to install. You just need a bit of PowerShell to do it. I've actually written a blog on it, which is there if you're interested. When it comes to actually on-prem password changes, ban password is a very similar message. In fact, it's exactly the same message if you failed the on-prem policy. Okay, so it doesn't give you any hint that it's to do with the ban password list. You can enable audit mode, or you can enable enforce. I'd say recommendation, put it in audit mode, see how many bad passwords you're getting over a period of time, educate your users, and then switch it to enforce. And we get actually very meaningful messages in the event logs. In terms of licensing requirements, I never discussed licensing, but I thought I'd just put it in. Cloud-only users with Azure AD, it's a free edition. You get the global ban password list. If you want to use custom, you need at least Azure AD Basic. If we're looking at using hybrid users that are coming up from on-prem, then we need a P1 or a P2 license. Again, I put a link on here to give you some more details about actually installing it. It's a Microsoft link to help you. Whoops, wrong button. And then you might have a most wonderful password, but you might still get blocked. And the reason you might still get blocked is that wonderful password has been detected the fact that you got leaked credentials. And you could be flagged with leaked credentials as high risk. Right? And with high risk, what we can do is you can actually be blocked. You're encouraged not to be blocked. You're encouraged actually to make the user jump through a few hoops, such as changing their password. If you've not got multi-factor installed, which you should have multi-factor running, you can force multi-factor registration at this point in time. To get this, you need P2. If you want to find out more, I do have a 5-day masterclass where I go into huge amounts of detail on all the difficult stuff in Azure AD. The last thing to ask you is, please, can I get you to fill in an evaluation? It's not just the eval itself, it's the numbers that we get back. Otherwise, we don't get registered in the system. As an external speaker, it's very, very important we get our results registered in the system, and to get that, there's a threshold we have to get over. And that's it in 20 minutes. The train has just left. We missed it. Thank you for coming along.